Okay, so I'm trying to get some opinions on this, and I'm doing this in Greenfoot, but I think a really powerful tool at the middle school level would be to explore the coordinate plane and commands, like a robot. And my idea would be to, and this would be, I think, a great example of computational thinking, where it's not necessarily kids are doing deep programming, but they are creating algorithms for solving a problem. And I know computational thinking is not the entire spectrum of computer science, but I do think it's important that they start it, and I think that this could be a good example of it. So I want to show you and also have a couple questions about it. So basically my idea, and I'm doing it in Greenfoot right now, which is essentially what will lead to my question in a minute. But I would want kids to see just essentially this, where all they have to do is come up with commands. And the only commands that they can have would be a move and a turn right. So not a turn left or anything else, just a move and a turn right. And we would explore the coordinates on the plane. So one problem was you can give them a sequence of commands, and they would have to tell you where the robot would end up. You'd have to give them a starting direction, like, okay, you're starting at the origin and you are facing east. Where would you end up? And they have to give you that. The other type of problem you could see with this is, which would be more of like a create, is to tell them to come up with the steps to get you to say 5-3, okay? Because to turn that right going to 5-3, you're going to actually have to make a left, and they'd have to think of an algorithm to get there. But I'll show you what this would do. Now I'll show you my question, or tell you my question. So there's the move, the turn right, and the two moves. So they would be at 1, -2. And that's how they would answer that question, and they can test it with this program. But obviously Greenfoot's got, it's script based, and it's got other stuff that they wouldn't need to know. And right now I even have like a list of commands, which obviously they wouldn't need to see that, but the list of commands is to be able to tell the program what to do, and then see it do it after that. Because the way that Greenfoot's set up, at least, I could do it without any kind of data structure, but it would just immediately take the robot to like 1, -2 in that example, and not actually show the sequence that it's moving, which still would be powerful. But I think them just seeing the steps one by one would be powerful to be able to test their thoughts on this type of program. So the reason I'm sending you this is I know that most of the stuff in the middle school, if they are getting into the computational thinking aspect, would be drag and drop, which, I looked at Scratch, and I looked at App Lab, which App Lab's for apps, but through code.org, and I looked at Pencil Code or Pencil something. It was also drag drop. But all of those programs had a function in it called like go-to that accepts the X and the Y coordinate and gets the turtle or whatever the object is to that point. And really, my thought is that's kind of the whole process we want them to get to, is to come up with that go-to method. So I'm trying to think of another tool or program to use. I wanted to see if you had any idea of what we could use. But basically I would want to see what basically I showed you here. Students come up with just, maybe 10 different commands: move, turn right, move, turn right, whatever. And then be able to see it with the program, it execute, and them to be able to figure out, what coordinate it is, because it's a 5th grade math standard for the coordinate plane. And of course you would have to use it all in middle school, which is where you're really just developing that sense of the Cartesian plane and You know, whenever you get into anything, trig or whatever, you have to have a good understanding of, you know, X gets bigger as it goes to the right and so forth, Y gets bigger as it goes up. So just to ask you about the program to use. And also, I know that we can create a lesson that does not hinge on the program that we would use, but I'm wondering if we should at some point start getting together and figuring out these are the things that we will expose them to. If it's Scratch, if it's, you know, whatever, we want to pick a couple of tools that we think that would be good, and then we can kind of explore what you can do with those programs, because I feel like we have to know what will be available to be able to figure out what we can do. And lastly, I just looked up